Good evening friends. Today we are starting a new topic of speed, time and distance, and this particular topic of speed, time and distance has been in many times asked in NTSC exam, and this has very much relevance to the other questions as well that has been asked in this particular pattern of exam of NTSC. Now first of all we would like to see that what this is all about. So our speed concept is basically dependent on two parameters of distance and time. In short, we can say that if we know the distance that a particular person or a particular vehicle or anything travels divided by the time that it takes, and if we divide both these quantities, we will get the particular amount of speed. Now distance is mainly measured in meters, kilometers or miles, and time is basically measured in second, hour or minutes. So in this regard, speed has an unit of kilometer per hour. It can have meters per second or others. These three parameters are all basically connected with each other in a linear way. Like from this particular equation, we can always find out the time as distance upon speed. Also, if you want to calculate the distance from the particular equation number 1 itself, we can always derive that this speed and time can be multiplied to get the distance traveled by anything. So these three things we get when we talk about speed, time and distance, and most of the time everything is calculated based on these three equations. Okay, so a better approach to solve this kind of a speed, time, distance relationship is that we always have a view in a pictorial form. Like suppose a body is at A and it travels along a path and gets to a point B. So we can make this particular picture, and we can always allocate that at what distance it has traveled, in what time it has traveled. So these things, and if we know the distance and if we know these quantities, we can always get speed is equal to x upon t. And vice versa also, we can think that we know the speed, we know the time, so we can know the distance. We know the distance, we know the speed, we can get the time. So this is the base of speed, time and distance in this regard. Okay, now one more thing. The most frequently asked question is of average speed in various competitive exams, in NTSC and other exams as well. So what happens that, when it asks about average speed between two things, like if a body is at A and it travels across at a point B, so they give us the speed from A to B, and they give us the speed from B to A. Normally in normal questions they give us this particular thing. So this is one pattern of question that the distance is fixed. Distance is, let us say the distance is x. So the average speed is always calculated by total distance upon total time. Now if you look at this particular picture, when A travels from A to B, the distance travel is x. When it travels from B to A, distance travel is x, so total distance is 2x. And time, we can say from A to B it's t1, and from B to A it's t2. So this way we will get the average speed. We'll look into the details of deducing the average speed in other terms by looking into the questions. So let's move now to different questions. Okay, so we'll now add one question regarding the speed, time and distance. So the question tells that a tortoise travels 1 kilometer in 4 hours. After every kilometer he rests for 20 minutes, and we have to identify the time taken by him to travel 3.5 kilometers. And we have various options for this. So the baseline here in this question is this 20 minutes. It rests for 20 minutes. It's saying that it will travel 1 kilometer in 4 hours, and after that it will take a rest of 20 minutes. Okay, we have to calculate that at how much time it will travel. 3.5 kilometers. Okay, so 1 kilometer it took 4 hours plus 20 minutes to rest. Okay, now for 3.5 kilometers we will see how it takes. For 3.5 kilometers, initially it has to travel 1 kilometer, 1 kilometer, 1 kilometer. Like a pictorial representation, I can show you this, and this. This is 1 kilometer, this is 1 kilometer, and this is 1 kilometer. In 1 hour, in 4 hours, in 4 hours, and in 4 hours. So this 3 kilometers it took, plus this 20 minute, this 20 minute, and this 20 minute. So how much it is total as of now? It's 4 plus 4 plus 4 plus 4 plus 20 plus 20 plus 20, 60 minutes, that is equal to 1 hour. So it is 13 hours as of now. So it is how much? 13 hours. It is traveling 3 kilometers. We have to calculate 3.5. If it travels 4 hours, it takes 1 kilometer. So for 0.05 kilometer, it will take 2 hours. So 3 kilometers, we have 13 hours, plus 0.5 kilometer, we have 2 hours. So total we have 14 hours. So in this way, this C option is correct. Okay, so now let's see a different aspect of speed, time and distance in question number 2. Here it says that A and B are two stations that are 390 kilometers apart. Okay, these are 390 kilometers apart. A train starts from A at 10 a.m. At 10 a.m. it starts, travel towards B, it travels this way from A to B at 65 kilometers per hour. Another train from B at 11 a.m. and travel towards at 11 a.m. and travel towards A at 35 kilometers per hour. Okay, so the main logic or the main thing to solve this question is this particular distance. And this question asks that at what time do they meet? Train is going from this to this way, from this way to this way they are coming, and when they will meet at each time. And the speed and other parameters are given. So I have this particular thing, distance, and I have to keep this thing in mind and then go for the approach. We can go by, we have the time thing at 10 a.m. and 11 a.m. and the speed thing and the distance thing. But a new approach can be like what? Suppose it takes t1 time. I mean, suppose suppose it takes x time to travel this distance. X is the time to travel this particular distance where they will meet. Okay, so this is the thing that I have, the total distance. So if I have the time and if I have the speed, I can calculate the distance as 65 into x. How? Speed into time, plus if this is x, this time is x, I am taking at 10 a.m. This is traveling towards A at 11 a.m. It means after 1 hour. So if this is x, my other time will be x minus 1, because this is less than this one, and the speed here is 35. And we'll equate both these distances to what? Total distance. Total distance, I mean the speed and time, and the speed and time concept is here. So the equation we have is 390 is equal to 65x plus 35x minus 35. Okay, these two will calculate to 100x. This will come here, that is 390, 35. So 425 is equal to 100x. So x is equal to 4.25 hours. Options are 2.15, 4.15, 3.15, 12.15. So it started at 10 a.m. plus 4.25 hours. What would it be? 12.25? 2.25 hours. But you will see there is nothing called as 2.25 hours. This is 0.25 hours. 0.25 hours is what? How much? It is 15 minutes. Because total 60 minutes are there in an hour. So it is 25 of that. So that will calculate to 15 minutes. So my answer will be at time is equal to 2.15 p.m. both these trains meet each other. Thank you.